of 9,000 Rontgens per hour.
What? 9,000? It's time for some more of that Chernobyl guy. Specifically, Firefighter fell onto Corium. Ouch. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering and operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's see.
In the early hours of May 23rd, 1986, a small team of firefighters found themselves battling a smouldering inferno in a highly radioactive area in the destroyed Unit 4. In their haste to locate the source of the smoke, one of them would fall through an open hatch, break his leg, and find himself
that sound effect was grisly.
Trapped in total darkness, directly on the former molten remains of Chernobyl Reactor 4.
Yeah, that must have been horrifying. I like that he specified former molten remains. Because he mentioned May 23rd, so almost a full month after the accident at this point. So by late May, the fission chain reaction was long dead. I mean, the chain reaction ended once the reactor tore itself apart. So yes, technically tripping the reactor did shut down the reactor by destroying it. So what remained at this point is decay heat, and the corium had already relocated. So at this stage, a month after shutdown, decay heat was roughly 0.5% of full power. Maybe 1% at most. Sounds low, but that's still multiple megawatts. And the main hazards in this case is going to be the corium geometry itself, gamma radiation, especially from shine, beta contamination, residual heat, and, of course, electrical fires. After all, this is the fire department coming in here.
To these damaged sections of the building to assess the damage and any potential risks. This would require restoring power to the building, so they could actually see what they were doing. Yet, there was no way to keep track of the tens of thousands of cables which had been severed during the building's partial collapse, and were now exposed, or even submerged in pools of water.
So after any major industrial explosion, cables are going to be shredded, insulation is compromised, mentioned water with damaged wiring, in the dark, electrical fires. All of that stuff is less of a nuclear problem and more of a post-accident heavy industrial facility problem. I mean, obviously it was caused by a nuclear event. But this sort of thing, yeah, Unit 4, a destroyed turbine hull attached to a damaged reactor building. Can certainly understand the electrical fire hazard at this point.
Ready to short circuit and ignite at any time. Staff at the Chernobyl MPP attempted to delay this reconnection of power, explaining the risks. However, pressure from NICIAT, the VG Coupling Radium Institute, and the Government Commission, all of which had sent employees to Chernobyl to assess the damage, forced them into turning the power back on amidst the risks. All they could do was hope. All hoped that it was safe enough to restore electricity without triggering further short circuits or fires. Thus, they
Hope is not a good word to use in emergency response procedures or in any real engineering operation. You don't want to rely on hope. You want to rely on design margin and calculations and redundancy. But here, yeah, it just shows how grim the situation was.
Restored power cautiously. Cautiously in this case, meaning they stood ready to cut it again if something began smoking. After power was restored, reconnaissance was quickly underway in the damaged portions of the building. Shortly before 2 a.m. on May 23rd, 1986, just 4 weeks after the initial explosion, head of the reactor shop Sergei Petrovich Lebedev was performing dosimetric measurements in the building.
It's a mess. And that's the way it is in nuclear power plants. You got piping, you got conduits, all of these large pumps, these big nuclear systems. Yeah, they are huge electrical loads. I don't know the voltage for the Chernobyl pumps, but these were comparable to reactor coolant pumps, and the ones at the plant I worked at were 13.8 kV. So these were likely similar. Medium voltage, bit on the spicy side of medium, but the point is, big conduits. And in a damaged facility, yeah, you're going to have cables that are going to be shredded.
And dangling after the explosion. Sections of the plastic floor covering had been torn up, and debris from piping and walls littered the passage. Alexander Agilov passed through the corridor on April 26th as he was assessing the damage with Sasha Yovchenko. He remarked, "Then we approached corridor 406, which connects one MCP hall with the other. What was there? First of all, darkness. Then, some cable boxes ran through here. These cables were hanging down. The plastic floor covering was all over the place. There were some building materials. In short, it was something awful. And going there was a bit frightening. We were extremely wary. I shined the flashlight and said, 'Sasha, don't touch the cables. They could be live.'"
I'm trying to think of the safety briefing for this whole operation here. So radiological hazards, electrical hazards, just normal bumping into stuff hazards because it's dark. Yeah, I'm used to having separate briefings for each hazard. So if you were to try to attempt to do something like this today at the plant that I worked at, well, for one, radiation protection would just say hell no. But it could become so complicated and cumbersome that you're going to be going through here, traversing very slow before you even get to where you need to go, just because of all of the potential hazards. Something awful is right.
Lebedev began his measurements from the entrance to the north main circulation pump hole, where his dosimeter read 300 Rontgens per hour. At radiation levels this high, workers in the sarcophagus would reach the administrative dose limit in mere minutes. Konstantin Chetarov of the Kurchatov Institute of Atomic Energy, who had explored the sarcophagus hundreds of times, later recalled, "At the time, a radiation level of a few tens of Rontgens per hour was considered normal, hundreds still acceptable, and only when the smell of ozone appeared, above 1,000 Rontgens, was rapid evacuation required."
Alright, let's break this down. That's ridiculous. So, again, a Rontgen is a unit of measure for exposure in air. Converting it to dose is going to be needed when you evaluate the effects on personnel. So convert it to rems or sieverts. Rough conversion, assuming it's gamma, which is likely going to be the case because those are going to be the things that have range. They have enough penetration to get through all these corridors that they would dominate the effects on the human body. 1 Rontgen is approximately 1 rem. It's not exactly conservative if there's stuff other than gammas mixed in, but it just makes the math easy for now. And in a lot of cases, it's still a good approximation. So 300 Rontgens per hour is basically 3 sieverts per hour. 1 to 2 sieverts is where you start getting acute radiation sickness. And 4 to 6 sieverts is the LD 50-60, 50% of the population gone within 60 days. Though I will say these administrative limits, I don't like the term acceptable, but yeah, especially for back then, that may have been the case. Now, the threshold for emergency workers for a job within the US is 25 rem, or 0.25 sieverts. That one requires explicit emergency director authorization, and the individual doing this job must be a volunteer. This is according to the US Nuclear Regulatory Commission. So I know this won't apply to Chernobyl, different regulation, but that's the number I'm used to. The administrative limit normally is 50 millisieverts per year, which is 5,000 millirem or rem. That is to say, 1/5 of this individual limit. The term the NRC uses for this is called a planned special exposure. And anything over 25 rem, it has to be a volunteer. Now, between 5 and 25, it still requires emergency director to sign off, but the individual doesn't have to be a volunteer. You can actually make someone do this. Keep in mind, for added context, the lowest dose for which an increased risk of cancer over time is evident is 100 millisieverts, or 10 rem. So this several hundreds of Röntgen per hour, to use their units, is not at all acceptable. Though, per hour, you still need to, during the radiological briefing, you need to do a unit conversion. Because after all, if the exposure time was 5 seconds, it would be considered acceptable. But you need to take into account an estimate of how long the job will take. But using the special rules in emergency triage for a very limited time, yes, it could be considered acceptable. And as far as the smell of ozone thing, no. No radiation dose limit is reliant on human senses.
Measurements were still within acceptable levels. Acceptable, of course, being a flexible term in May of 1986.
Yeah.
And so, Sergei carried on with his work. Moving swiftly, he marched south through the corridor, measuring 200 Röntgens per hour near staircase 257. The staircase...
One more thing I will add to that is, in the context of Chernobyl, radiation work was still dose budgeted. People were used like limited life components, which is really grim.
Led up toward previously assessed corridors, but also down into unexplored territory. One floor below was Corridor 301-6 on floor +9, connecting maintenance equipment to the sub-reactor space, room 305-2. Descending another floor led to the cable corridor 217-2 on floor +6, later infamous for reasons unknown to him. As he neared the stairs, his dosimeter surged, and the device had reached its upper limit.
That's not good. Okay, so if we're talking decay heat, it does not produce radiant upward heat like a furnace. Heat transfer, if this is from Corium, would have to be direct conduction through the concrete or convection if air paths do exist. And we're talking late May, so the decay heat, the temperature of the corium, would have dropped dramatically. So this intense heat is likely going to be from an electrical fire, localized burning debris, something that actually is burning and radiating like a furnace.
The risk was far too high. It would take months before those floors below could be accessed.
Sure.
Continuing south along the corridor, he recorded further measurements, ranging from 100 to 200 Röntgens per hour. Beyond the stairs, the floor was scorched black, evidence of something extremely hot. The unusually high radiation, combined with the burnt flooring, indicated a source of intense heat and radioactivity directly beneath him.
One thing about these electrical fires, it is possible if something ignites, it can push radioactive particulate matter and lead to higher dose reading, which, as we know, with anywhere near this destroyed Chernobyl building, there is plenty of radioactive particulate matter.
At the end of the long corridor, he entered the south main circulation pump hole. There, his worst fears came into fruition. Their hope had been misplaced. What he saw was thick, black smoke filling the room. Chernobyl Unit 4 was on fire. Again. He quickly radioed his superior.
Not the same type of fire, not a reactor fire. I mean, this is going to have to be an electrical cable fire. And after all, nuclear plants are filled with miles of polymer insulated cable, thousands of miles even, plastic floor coverings, oil systems, and nuclear power plants are very particular about fire loading. There's even permits you have for transient fire loads, which is literally just about any material you're going to store in any room. The reason why it's a fire load is an evaluation needs to be done and signed off by the fire marshal if material is going to be in a room stored there temporarily for a certain period of time. But the Chernobyl accident didn't politely go into each room and made sure all the fire loading was good before it happened. It took things through rooms and smashed rooms into each other and all the associated material post-accident. So, yeah, it's not like it waited for your fire loading to be optimal.
While hastily making his way out of the building. Within a few minutes, the local fire departments had been alerted. After being informed of the high radiation levels in the premises of the fire, 50 to 200 roentgens per hour, they decided to alert as many fire brigades as they could. First, they alerted the fire brigades stationed in Chernobyl town. This included several firefighters from Pripyat, Kharkiv, Chernihiv, Kiev, and pilots from Zhytomyr, totaling 138 men in the main body heading north towards the nuclear power plant. Many more would voluntarily join the fight against the blaze, totaling 282 firefighters by sunrise. The man in charge, Vladimir Maximchuk, had decided to combat the blaze in a way that would limit the radiation dosage for his men. He would send in groups of just 5 men into the southern pump hole, and he instructed them to immediately leave once they had completed their task.
That's actually decently good radiation protection. It's all about time, distance, and shielding. So limit exposure time, rotate your crews, minimize cumulative dose per person. So under this chaos, that's actually a good way to do it.
And they would be replaced by yet another group with the same instructions. Maximchuk was the only one to remain in the pump hall for an extended period of time.
Now that's not a good thing, though.
Only leaving when another group was to be called up. The first group of firefighters were able to quickly assess that they were dealing with a major electrical fire, and so they cut the cable to the burning areas. From outside the pump hall, they cut open a cable box and inserted a hose into the cable pipe that would lead to the burning portions of the southern pump hole, attempting to smother the blaze with water. Eventually reaching their dosimetric limit, they left, and another group went in and found another entrance to the cable shafts, inserting another hose. Eventually, using these groups of 5 men, they were able to set up a network of hoses through the cable shafts, and they began pumping water in, intending to smother the fire.
Now, one thing about pumping water into cable shafts, floating cable shafts in a damaged nuclear plant does have the potential to spread contamination or even create radioactive runoff. So it's kind of a double-edged sword at this point. You do still need to stop that fire, though. Tough call.
Detonating them inside a partially collapsed nuclear reactor was another matter. However, their orders stood. Get in there in small groups of no more than 5, try extinguishing the blaze, and leave after no more than 10 minutes. The first of these new volunteers went into the southern pump hole, and it took only 4 minutes for them to identify the source of the fire. They were able to look down into the cable tunnel and see a bright, glowing light, accompanied by flickers of fire and thick black smoke.
There you go.
Within another 4 minutes, they had extinguished that cable fire using foam. It turned out the fire was not as large as they had initially thought. The fire was ultimately traced to a cable shaft. In a building full of nuclear fuel, it was an electrical fire that proved most persistent. However, they had no time to celebrate their victory. At around 8 a.m, another cable fire had broken out, this time closer to the eastern end of the southern pump hall. One firefighter, trying to find the source of the blaze, thought he found a lead. A large, square hatch on the floor seemed to be radiating an intense heat. He opened it, and nothing. No smoke, no fire. Just heat and darkness below. He left it open, and then helped his comrades to battle the blaze in 402-3. Yet again, they were able to quickly extinguish this blaze by directing a jet of water into the cable tunnel. Before they left, they decided to quickly check the area for any smouldering blazes that could ignite again. As they split up, one firefighter scanned the corridor 406-2 toward the north pump hole. Smoke still lingered in the air, cables still dangling from the ceiling. He was unable to see any sources of fire and smoke, but he had to be sure, so he kept looking. His vision narrowed, focused on the far end of the corridor. Then, in an instant, the floor disappeared beneath him.
Oh no.
He fell nearly 2 meters into the corridor
Wow.
below. He landed on a piece of maintenance equipment suspended from the overhead railing. The hatch above had been designed to allow this equipment to pass through, and for some reason had been opened. It broke part of his fall, but he still hit the floor hard.
Yeah.
His legs absorbed the impact awkwardly,
Ooh.
and he felt a sharp snap. His leg had broken on landing.
Brutal.
All he knew was that he had fallen into a dark corridor, so dark he couldn't see the floor beneath him. And it was hot. Incredibly hot.
Wow.
The kind of heat that pressed against his skin and melted his boots to the metal equipment under him.
Okay, that's hot. So if boots were melting, temperature is going to need to exceed 200, maybe 300 C. I know the title of this video said, fell on Corium. Now, is Corium that hot over a month after shutdown? Likely not at the surface, but it can remain hot internally. It's possible some localized deposits could get above 200 C. Also, cable fires can produce extremely high localized temperatures. I've seen enough electrical testing to know that even before the fire occurs, these electrical components can get super hot. It's one of the reasons why you load bank test everything when you put a new breaker in service.
The air smelt of burning dust, and more worryingly, ozone. However, for him...
So, electrical arcs can account for a smell of ozone. Radiation doesn't smell. Ozone's going to come from ionized air from electrical discharge. That's probably the more likely case. We've talked about energized components catching fire.
That was the least of his concerns. He couldn't move without a sharp, unbearable pain shooting through his leg, and he couldn't climb out himself. So, he called his comrades for help.
Yeah?
Found the source. The open 2x2 meter hatch just beyond the end of corridor 406-2. Inside, they found the unlucky firefighter, but also immense heat, radiating upwards from the hatch, as well as a faint metallic taste in their mouth. It was all too familiar.
So metallic taste in the mouth is a radiation symptom description, but metallic taste could also be anxiety, stress response, ozone, or an extremely high acute dose. It would not happen immediately at 200 roentgens per hour. So either the dose field is way different for him down below than it is up top, or it's something else.
They were able to find a wooden board, where in less than 2 minutes, they were able to tie a rope to it, and then lower it down to the unfortunate firefighter. He grabbed on, and it took 3 firefighters to pull him out, where he was quickly rushed away to a hospital. We will talk about what happened to this firefighter later. As more firefighter teams were rotated in and out, the fire continued, and another cable shaft had ignited in room 403, north of the pump hall. Unable to successfully
the
extinguish the
Hydra.
blaze using water, they chose to use foam.
Stop one, another one ignites. Two more ignite.
This change in plans had occurred far too late, as their water had already flooded the transport corridors below. Before they could proceed in using foam, they had to seal the drains that would take water away from the cables to the transport corridor. So they did. A few shifts, 30 minutes, and the job was done. Finally, they could fill all the cable shafts with foam. For the moment, the fires were extinguished. Over the coming hours, some smaller blazes would ignite in the building. However, Nikolai Steinberg simply decided to let the fires burn themselves out, rather than risking the health of even.
At some point, you just need to make that call, as in, is the harm of the fires worse than the harm of sending someone in to deal with them?
More firefighters. His plan worked, and no more blazes would ignite following May 23rd. The firefighters who rescued the firefighter from the hatch reported to their superiors their accumulated dose that their dosimeters had read. The number was so high that their superior didn't believe them.
Wow.
And they were denied leave from the exclusion zone. The fates of these firefighters were not documented. In
That's
the bunker,
suspicious.
the government commission had to deal with the fact
I take we don't know their accumulated dose either.
that their impatience had led to a needless fire that had irradiated countless firefighters and given one life-threatening injuries. They chose to halt their plans and disconnect Unit 4 from the electrical grid. And so, by May 26th, Unit 4 was once again separated from the rest of the building. Within the weeks following the blaze, the government commission found themselves between a rock and a hard place. They urgently needed to explore the building, assess the damage, locate the fuel, and determine how much of it had truly escaped the building into the atmosphere. Alexander Borovoy, a scientist in the government commission who would eventually become a key figure in sarcophagus research, was the first to try and tackle this issue. He developed a mathematical model to determine the activity of radionuclides and their spread in the building, to try and determine how much fuel remained inside. This was followed up by a more advanced model developed by Valery Legasov, which came to the conclusion that 90% of the nuclear fuel remained inside the building.
Yeah, despite the explosion, most of the fuel did remain within the confines of the structure. Again, it was a steam explosion plus graphite fire rather than a nuclear explosion. The fuel was fragmented, but most of it remained on site.
The next step was finding the missing fuel. Enter Konstantin Chernobyl and several employees from the Kurchatov Institute of Atomic Energy. Over the next few days, Chernobyl conducted several flights over Unit 4 with a temperature sensor. The readings he got simply didn't make sense. Inside the core was a mere 24 degrees. He couldn't find 100 degrees, let alone 1000, and a mere 150 rontgens per hour emitting from the core. Yevgeny Velihov remained indignant, convinced the instruments were broken, or possibly lying. This can't be true. What did you measure? It's the reactor shaft. There's melted fuel there, and the numbers should be higher.
Interesting that this is going in the opposite direction, that they think it should be higher now rather than they thinking it should be lower.
Chernobyl knew what those readings had to mean. The core was empty, devoid of fuel. It must have all escaped the core and spread out through the building, like lava. He just had to prove it. As of yet, none of this supposed fuel lava had been located.
Fuel lava.
And as he was the one suggesting such a ludicrous idea, it was now his responsibility to find it. By June 9th, he, along with several Kurchatov employees, were going back into the sarcophagus, this time in the dark, to locate the fuel. First, they assessed all the safe areas. Everything above the sub-reactor space, starting from plus 12.5. They began their assessment. One of these employees was dosimetrist Mikhail Sergeyevich Kostyakov, one of the more senior colleagues, and a veteran whom fought the Japanese in World War II. He was an expert in his instrumentation. He redesigned his DP5V dosimeter, making it several times faster, although with a higher margin of error. But they didn't need precision. The main thing was to assess radioactivity levels, and do it quickly, to minimize their own dose.
Yes.
On the 10th of June, Chernobyl, Kostyakov...
Any sort of assessment, it has to be done fast, because it comes back to time, distance, and shielding. And if you can minimize time, that's huge.
And another dosimetrist, Vladimir Ivanovich Kabanov, were working in the south main circulation pump hole, taking measurements and assessing damage from the previous fire. The room was covered in a layer of soot, and there was no light except for the shining coming from the headlamp of their miners' helmets. Entering from the western side, they measured up to 200 Rontgens per hour, reaching the middle of the pump hole. Kostyakov chose to continue on along while Chernobyl and Kabanov took more detailed measurements in the pump hole. Kostyakov made his way towards the eastern end of the pump hole, and was about to enter the long corridor 406-2 when he found the open hatch in the floor that he was looking for, about 2 meters in diameter. It was difficult to see in the darkness, so he walked carefully, and as he approached the hatch, his dosimeter surged and went off the scale, above 1,000 Rontgens per hour.
Ooh,
he stepped
that's
away from the
spicy.
hatch and continued his survey. He entered corridor 406-2 and followed it to the northern main circulation pump hole. He measured the radiation at the northern pump hole's entrance, where it was around 200 to 300 Rontgens per hour, and turned
just
back.
like they initially thought.
He passed the hatch more quickly, knowing the levels there. That evening, Kostyakov returned home for his evening meal with his colleagues, and he scratched the side of his leg. The skin was peeling. He had sustained a beta burn from walking near the hatch for only a few seconds. This meant extreme radiation levels, which had to be investigated further. Maybe they had found the fuel. So he reported his findings to Chernobyl.
That's not a good way to find the fuel, by getting beta burns.
On the 11th of June, Chernobyl returned to the pump hole, this time alone, to try and measure the dose within the hatch. Armed with the best dosimeter he could find, rated for 9,000 Rontgens, it was, at the time, considered more than sufficient. He began to approach the hatch, when even that went off the scale. In the vicinity of the hatch, there was a minimum radiation level of 9,000 Rontgens per hour.
What? 9,000?
The instrument had reached its upper limit. He had still come prepared. He strung together 6 500 rad accumulators spaced half a meter apart, then ran to the opening, lowered the string, and quickly moved to an area with the lowest background radiation he could find. 15 minutes later, he returned.
When you find something you don't expect, you try to find the lowest dose area to assess. You don't sit in the area and say, I wonder if this is accurate or not.
Pulled out the string of accumulators and did the maths using the readings they had measured. He determined that at the floor level of the pump hole inside the hatch, the dose rate was 10,000 Rontgens per hour, and inside the hatch, a meter above the floor, it was 11,400 Rontgens per hour.
Wow.
Over 3 Rontgens per second. Enough to deliver a lethal dose to half of the people exposed in under 3 minutes.
Okay, so he's talking for LD 5060 numbers. That's going to be in the 4 to 6 sievert range. So yeah, roughly, if that number is indeed accurate, then that's within that order of magnitude. And that's plausible. There's going to be some corium shine levels in this general vicinity.
Radiation levels this high had not yet been encountered inside the building, and Chernobyl believed he may have found the fuel. However, he could not investigate further,
Yeah.
as even being near the
Maxed out.
hatch posed a risk to his life. Little did Chernobyl know, he was entirely right in his assumption. Chernobyl investigated more remotely. He consulted the floor plans and identified the hatch. It was located near the eastern end of the southern pump hall on level plus 12.5, and descended one floor to corridor 301-6 on level plus 9, the same level as the sub-reactor space beneath the reactor. Could it be that fuel had travelled out from the reactor into the sub-reactor space, then to 301-6 and down to where the hatch was? There was an obvious path for the fuel to take, but there was only one issue. The hatch was over 20 meters from the sub-reactor space. Surely.
So this is plausible. Gravity plus slope structures plus heat. I mean, it's a viscous lava-like substance. So what corium actually is, it's uranium fuel, zirconium cladding, sand, concrete, steel, and control rod materials. It's a lava-like mixture of things, and it flows because concrete decomposes, rebar melts, and the structural floor weakens. So gravity can do the rest by itself. The 3 Mile Island accident also had corium relocation, just a lot less and all contained within the reactor containment vessel, so it wasn't really an issue of concern compared to Chernobyl anyway.
He thought. There was no way fuel could have travelled that far from the core. However, there was only one way for him to find out. Over the coming weeks, Chernobyl, Kostyukov, and Kabanov attempted to find a safe access route to that corridor. However, they could find no clear route. Attempts from plus 12.5 via staircase 257 proved to be far too radioactive, and the same went for staircase 256. The only other option they had was to try to find an access route from beneath. However, they didn't have much time. Soon, all expedition work was to be halted to allow for the construction of the sarcophagus, and the pouring of concrete into the structure. So, later that month, Kostyukov and Kabanov set off, from the clean staircase on the ground floor. They made their way through the corridor 025-3 toward 017-2. And when they entered the corridor, they found the ascending staircase to their left that they were looking for, that would take them to 217-2 on plus 6, where they could try getting to plus 9 from the floor below. However, when they raised the dosimeter up the stairs, the readings began sharply increasing, and when it reached the threshold at the top of
That's what's so crazy about this, is at specific angles, geometries, elevation, one room to another, the radiation dose rate can vary quite a bit.
It went off the scale, 3,000 rontgens per hour, and broke.
These ridiculous numbers.
They decided to just leave the dosimeter there and turn back.
Yeah.
Declaring yet another attempt unsuccessful.
If it broke, there's no point taking it with you.
Kostyukov and Kabanov did not know yet, but at the top of the stairs sat the elephant's foot, Chernobyl. Now with all possible routes to access being far too radioactive to traverse, gave up. And as the construction of the sarcophagus began, it wouldn't be until December that he could try again. However, by that time, he had lost interest in sending Kostyukov and Kabanov to find yet another impassable route.
Lost interest. I love the phrasing
By
of that.
mid-December 1986, Vasya Koryagin, a speleologist at the Kurchatov Institute, had devised a plan to access the sub-reactor space 305-2. Koryagin had a particular obsession with the bottom of the reactor, like an itch he needed to scratch. And so, without any help from Chernobyl or his superiors, he set off alone. Koryagin's devised route involved descending the staircase 257, down to plus 9, and taking a left into 301-6, and then his first right into 318-2. and from there the first door on his left would lead to 305-2. As fate would have it, Corium somehow missed the floor he was supposed to exit staircase 257 at, and ended up leaving the staircase on +6.
Three-dimensional maze.
The corridor into 217-2, where he came face to face with the elephant's foot, and became the first person to truly discover it. After Corium's discovery, Chernobyl was finally informed, and so he went to the foot himself to see what it was. He found the object to have a black, glassy appearance, like lead,
Yeah, the
and this
lava
is what he
substance.
initially believed it to be. However, Chernobyl was skeptical, and believed it could have been nuclear fuel, and so he ordered for samples to be taken, something that would take several more months. Chernobyl's skepticism stemmed from the fact that research by the Government Commission had shown that nearly none of the lead dropped by helicopters could have made it into the core, let alone this much, paired with the extremely high gamma radioactivity of 8,000 rontgens per hour that he had found. Chernobyl reminisced about his discovery
these
of
really high
radiation in
numbers.
Hatch, and what it could mean when linked to this new discovery. Consulting the floor plans once again, he found that where the hatch led into, 301-6, was directly above where they had found the elephant's foot in 217-2. Could it be that the radiation he found in the hatch was in fact from nuclear fuel, like he had initially believed? Had a firefighter in May fallen into a corridor filled with once molten nuclear fuel? He couldn't be so sure, and he didn't have any concrete proof at the moment. By the spring of 1987, the analysis of samples taken from the elephant's foot proved Chernobyl's theories. The lava contained not lead, not boron, not dolomite, but zirconium, sand, serpentine, other parts of the core, and, most importantly, nuclear fuel, originating from Chernobyl Reactor 4's fuel rods. They had found what they were looking for. There was only one question. Where was the rest of it? Alexander Borovoy, head of the complex expedition, was assigned the task of locating the remaining fuel. By the end of 1987, additional accumulations of fuel were discovered, sometimes only after cutting new openings or demolishing interior walls. Yet a significant portion was still unaccounted for. The evidence increasingly pointed towards level +9, the level directly beneath the reactor, the same level into which the hatch descended. Unfortunately, much of that floor had been entombed in concrete during the construction of the sarcophagus, making direct access nearly impossible. Borovoy proposed drilling boreholes into the sealed sections of +9 to locate the missing fuel. The plan was approved under Boris Shabina, and a reorganized expedition under the Kurchatov Institute began preparations. By the spring of 1988, many boreholes were operational. What they revealed would finally clarify what happened on +9. The nuclear fuel had escaped from the reactor into 305-2, from which some fuel descended vertically into the steam distribution corridors. The rest of it escaped horizontally, melting through the wall into 304-3, where it then spilled out into 301-5, and then east to 301-6. From there it flowed out and filled the southern end of the corridor with a layer of corium up to 30 centimeters thick, spreading all the way to below the hatch. From there, it descended through cable holes further, into the corridor 217-2, where it formed the elephant's foot and several stalactites. Chernobyl now had the full picture. The hatch, which was a seemingly unremarkable feature of the southern pump hole, was in fact positioned directly above one of the most intense accumulations of nuclear fuel in the entire building.
And somebody fell through that.
Radiation he had measured months earlier, which had sparked both curiosity and concern, was no longer a mystery to him. It was the innards of reactor number 4. We can confidently say that, on May 23rd, 1986, a firefighter literally fell onto Chernobyl's reactor 4. Now we need to talk about the elephant in the room. What happened to the firefighter? Well, we aren't quite sure. In an article published by
That's
Alexander
what's the
Kuprin,
craziest part.
containing a memoir from Konstantin Chernobyl, Chernobyl states that the firefighter later died of radiation sickness. This is vague, but it makes sense. The firefighter fell into a zone that would provide a lethal dose in literally 2.5 minutes. In the amount of time it could have taken to rescue him, he very likely could have received a lethal dose.
Yeah, we're talking 10,000 R per hour, even, 60 to 90 seconds would deliver multiple sieverts. So acute radiation syndrome, hospitalization, documentation. And yet there's no clear hospital records here. That is highly suspicious. So it's possible the dose was lower than later measured. It's possible he fell near but not directly above the peak corium. It's possible he was somehow shielded by some structure. But with incomplete records, your guess is as good as mine.
There is only one problem with this: the lack of documentation.
Yep.
According to David01, who runs the Chernobyl Revisited YouTube channel, and has access to many of the hospital records, no firefighter was admitted to Moscow Hospital 6 with a high dose, let alone died, in late May to July 1986.
I was going to say all the firefighter fatalities were earlier, the documented ones, that is.
Supposedly, people were being admitted with doses as low as just 10 rem, which this firefighter would have received in only 5 seconds of being in the hatch.
Yeah.
But there's a counterpoint to this argument. The hospital records sometimes left people out, and perhaps the hospital records were originally shared incomplete, and therefore lack the concrete certainty we need for this. Furthermore, the firefighter could have been transported to other hospitals. It is known that hospitals in Kiev were accepting patients from Chernobyl. Among them was Alexander Lenachenko, an electrician who remained on site from April 26th until early May, and was one of the first victims to succumb to radiation poisoning. What happened to the firefighter?
Lack of documentation is really, really disturbing. But it's interesting, because at this stage of the accident, it was essentially a post-accident radiological archaeology site. They had to reverse engineer fuel relocation, map dose fields, infer corium paths, and build models without instrumentation. In fact, modern severe accident codes are built partly on data from Chernobyl. And the critical lessons here are, corium can breach floors. Hydrogen and steam explosions can absolutely compound damage. And these fuel flow paths, relocation paths matter. And today we use robotics, gamma imaging, remote sensors, not people with modified meters going into the scary, dark, electrical, radiological hazard zone. I mean, there was some real courage and heroism here with these responders and dosimetrists who mapped it methodically, 1 Rontgen at a time, or maybe I should say 100 Rontgens at a time, given these dose rates. And at the time, they didn't know that if the floor beneath them was one of the most radioactive places on Earth. When you design your reactor, you shouldn't have to do that, have heroism built into your design at all. Thanks so much for the recommendation, and thanks so much for watching. I'll see you next time.